Yes, hello everyone. Welcome to your chemistry classroom. I am Lawal Adetunji, your chemistry tutor. As you have all known that NECO will be written, NECO Chemistry 2025 will be written in the next few hours. In the next few hours, like this morning, tomorrow morning. We have some questions we need to revise with that we can also call the likely questions from this platform. Our own is to get information and solve the question with you that you are watching us. We revise together. I will not. What you need currently now is to pick up your book and pen and start working on it, because don't feel disappointed if you see something like this tomorrow. I will not say more than that. So that's why I'm telling you this is a likely question you are going to see tomorrow. Question 1 is what you are seeing on your screen right now as I'm speaking. So what are you going to do right now? Please press your subscribe button, turn on your notification button, share our link with your friends that are writing NECO chemistry tomorrow. Share it with them right now. Share it with them right now and put your comment in the comment box, because I'll be asking us questions. There are some questions that also you also will put the answer in the comment box for me to confirm your answers. We are revising together. The first question here say 1A1, what is fermentation? And 1A2 say, with chemical equation only, show how ethanol can be produced from starch. That's talking about number 1. And I'm very glad to tell you that number 1 is compulsory, so you can't joke with this number 1. Don't skip any part of this video. Watch it from beginning to the end. You are the one writing exam. Take your time to watch, so that you have something to write tomorrow in your chemistry paper. Alright, the solution to that 1 and 2, I said fermentation is a chemical process in which enzymes produced by microorganisms, example microorganisms, we have yeast, we have bacteria, but here I'm mentioning yeast, break down organic substances such as glucose into simpler compounds, usually in the absence of oxygen. Now if it's in biology, we'll have called that one anaerobic, but this is chemistry. That is just a chemical process of breaking down what organic compound, that is breaking down of glucose to its components, to that is want to achieve ethanol or alcohol. Now moving forward to 1A2, with chemical equation only, they want us to show how ethanol can be produced from starch, how they produce alcohol. That's what they want to. That's what they are telling us. But using the equation only, I also use equation only to see. I said stage 1. I wrote starch. This is equation for starch plus water in the presence of amylase, that is the enzyme, to give me C6H12O6. That's the glucose. That's the end of stage 1. Stage 2, from where you stop at stage 1, you move to stage 2. So glucose, now the reactant at stage 2, I'm using cymase as the enzyme or catalyst. Now it gives me what? Ethanol and carbon dioxide. For them to have said you should write chemical equation only, that is, the chemical equation you will write must be a balanced one. You must balance your equation. Look at the equation very well. You can make pause and write the equation down, because you must write a complete and balanced equation. I think I have felt that situation. I move to 1B. The 1B is talking about the characteristics of halogen. And here we mention 2 halogens. They mention fluorine and chlorine. They say she states, they tell us the states, their state of matter at room temperature. And before that, this is what you want to feel. This gas, the way I put my hand is empty, is a blank for you to feel. This blank is for you to feel. Maybe I should use my red pen to let you know that it is a feeling, it's a line for you to feel, or it's a space for you to feel. So my answers are what I wrote there. So you said uses of fluorine, we use it for Teflon, and we use chlorine for antiseptics. That is to kill germs. So what's the state of matter of both of them at room temperature? And I'm very glad to say that both of them, they are gases at room temperature, and I've set to 1A, 1B. So going to 1C, this is a calculation, this is stoichiometry, but a simple one. They said how many moles are contained in 25 grams of magnesium triose carbonate 4, and they gave us the atomic mass of magnesium 24, carbon 12, oxygen 16. And how can we solve this? You need to know that magnesium carbonate, MgCO3, you need to break it down to get what? To get the molar mass of magnesium carbonate 4. And likewise, you know mole is equal to mass over molar mass. Pending the time, I will show you the answer. I want you to try it and put your answer in the comment box before I will show you the answer. Put your answer in the comment box before I will show you the answer. As you are doing that, share the link with your friends as I'm speaking. Share the link with your friends that are writing ECHO. Many people are writing ECHO nationwide. Share it. They're writing chemistry tomorrow. Share it with them. Let them benefit. Let them benefit. Let them benefit. Don't be the only one benefiting from this platform. Let them benefit. We are here for you. Alright, I am moving to my solution ground. You can see my solution. I said molar mass of magnesium carbonate. I worked it out. I got 84. Just work your own out. So know if your answer is different from mine. And I said mole is equal to mass over molar mass 25 over 84, and I got 0.2976 mole as the answer to the question that said how many moles are contained in 25 grams of magnesium carbonate 4. Please watch the video and be following the sequence. The video will not be longer. We are doing it orderly. After question 1, I'll pick question 2, question 3, orderly like that. In case the video is getting longer, I'll be cutting it to the next video, so that everything you have it comprehensively in your book, in whatever you have, and you're able to enjoy it. We are here to serve you better and nice one. So I believe we have settled question 1. I believe we have settled question 1C1. Now let's go and solve question 1C2. To solve question 1C2, they say you should name a suitable indicator for the titration of strong acid and a weak base. Like the practical chemistry we had, we use methyl orange. Why do we use methyl orange? Because we use strong acid and the weak base. So answer is methyl orange. The answer there is methyl orange. I think we have settled 1C2. So we are going to settle question 1C3. Please, as I'm talking right now, do well to share the link. The reaction we are receiving is still low. Share the link with your friends. You want this place to be more lively than this, wider than this. Many more people to benefit from this platform. This platform is to help and to assist, especially those people that are writing examination, so that will reduce failure in the gathering of candidates. Alright, so I think we have settled 1C2. I'm going to 1C3. This 1C3 says you should give an example of the following. What are the examples of acidic oxide, and what are the examples of neutral oxide? When you talk about acidic oxide, you are talking about let me say a compound, or let me say a group of elements in which one of them will be oxygen and the other one will be a non-metal. In short, what am I saying? The reaction, that's when you have oxygen being reacted with non-metals. Definitely we call it acidic oxide. I'm taking it far. We can see also have some like that in under example of neutral oxide. But let me just go straight to the point. When we talk about acidic oxide, we are majorly talking about the non-metallic oxide. Non-metallic oxide, that's just talking about acidic oxide. We can also find such a situation in neutral oxide. So when you talk about acidic oxide, when you react them with water, they will give you acid itself. So a good example of acidic oxide, we have CO2. CO2, as you are looking at it, if you react it with water, it will give you H2CO3. Look at SO2 as well as an example of acidic oxide. If you react it with H2O, it will give you H2SO3. Another one, I have NO2. If you react it with H2O, it will give you HNO3. So all these that I've mentioned here, they are examples of acidic oxide. What about for neutral oxide? Why do we call them neutral oxide? For that statement neutral, you can still remember your acid base salt story. So neutral is talking about the one that come anytime, any day. The pH scale, the pH value 7, It will not have effect even on litmus paper. And it's something that will make it to be neutral, that it will not favor acid, it will not favor base. That's what we call it neutral oxide. I mentioned 3, but here you are just to mention 1. I gave out, do you know that your carbon monoxide, that poisonous gas, carbon monoxide, is a neutral neutral oxide. It's a neutral oxide. Another one is N2O. N2O is a neutral oxide. Another one is NO. It's also a neutral oxide. I mentioned CO, N2O, H2O. Even, do you know your water? H2O is also a neutral oxide. Water is neutral. It's never acidic, and likewise never basic in nature. So that settled the issue of 1C3 that I said we should give an example of acidic oxide. Acidic oxide. Still on NECO 2025 chemistry. What are you doing right now? What are you doing right now? Have you shared the link? Have you started putting your comment in the comment box? Have you started pressing your like and share button? Have you turned on your notification button? Have you pressed your subscribe button? Alright, I'm moving to 1C4. 1C4. The question on 1C4 says something, and what is it saying? It says you should differentiate between hydrophobic and hydrophilic. We don't need to go far. Science is very simple. Hydro means water. When you hear the word phobic, phobic can be fear, it can be hatred. It can be fear, it can be hatred. What you hate, you will fear it or you ignore it. Why philic means like, or phi from like. So when you now say hydrophobic, it means that you fear water, you don't want to have anything to do with water, you don't want to interact with water, you repel water, whatever you call it. Out of all those things I've mentioned, that's the answer. In my point here, what did I write? I say hydrophobic compound. They are compounds that do not interact well with water. They do not interact well with water. Why? For hydrophilic, they interact well with what? With water. Moving forward, I move to the next point I mentioned. I said hydrophobic compound, they repel water, that is, they ignore water. Why? Hydrophilic, they attract what? They attract water. I think that one said to the issue of 1C4. Now I'm moving to 1C5. 1C5, they say you should give the IUPAC name of these compounds: CH3CH2COOH, and we have CH3CH2CH2CH2OH. The first one, CH3CH2COOH, is a classroom we have to teach, not to just be dictating response. Alright, saying 3 carbons. The first thing you check when you are dealing with organic compound, what's the functional group? The functional group is there, that is carboxylic, COOH. That is 1 carbon is already present. How many carbons altogether? We have 3 carbons. That is propanoic acid. Propanoic acid. Propanoic acid. Because that carboxylic function means alkanoic group. Alkanoic acid group. And another question here, now what's the functional group here? That's OH. That is, it belongs to the alcohol family. And how many carbon do you have? You have 4. So family of 4 in the family of alcohol, that is butanol. That is butanol, C4H9OH. And I think that's how we settle all number 1A, 1B, 1C. I told you number 1 is compulsory, you can't run away from it. That's where you have your highest mark there. So take your time to do it right. And 1D, they say you should define the rate of chemical reaction. What's the rate of chemical reaction? When you talk about chemical equation or chemical reaction, we have reactant, we have product, and there's a change in concentration of reactant or product per unit time. That's what we call rate of. Whenever you even hear rate means over time. So no story. So that's really, like I say, this is a change in concentration of reactant or products per unit time. It can be reactant, it can be product. Any one of them over time, as concentration is concerned, is called rate of chemical reaction. And I think the last question is at the back here. And the last question for number 1 said, you should state 3 factors that affect the rate of chemical reaction. It says you should state 3 factors that affect the rate of chemical reaction. And here I think I gave out 6. Temperature, your own just to pick any 3. Temperature, concentration of reactant, I repeat again, temperature, concentration of the reactant, surface area of reactant, presence of catalyst, which catalyst are you using, pressure, and the nature of reactants. That's how I settled question 1. That's how I said to question 1. I want to move to the next question. After question 1, we have many questions there which you have to answer 4. And this answering 3. Number 1 is compulsory. So the compulsory side of it has been answered. So I want to move to the next one. Turn on your notification button so that you'll be able to see the next video. If it is too long, it will move to the next video. So turn on your notification button and watch on the next video. It's still your estimator Adetunji and still on the platform estimator Adetunji TV. We are together. Let's continue and let's move to the next question.